manual for the manual program. It has a lot of flags, a lot of other things involved you can do. You can scroll down and see a whole lot of other stuff.
Hey,
so
Renee,
that's pretty.
can you make your text a little bit larger?
Text bigger. Yeah, you got it.
Us old guys have got eyesight issues.
All right. Yeah. So is that better?
That's good. It doesn't need to be that big, but that's cool.
I'll take it down 1. Okay. So yeah, so that's man. The next one is a flag that you can pass. Let's see. It is the -- help. So if you can do man -- help, it kind of gives you a little bit of what the manual says. If you don't want to open a giant thing, because as you can see, when we went to man, it opened up kind of in its own process. Once you quit it, it goes away. This help, -- help is helpful because it stays on your screen. So you're like, oh, I just need a flag. I don't need to see a whole lot of examples, that type of stuff. All right, the next one is going to be the ls command. I'm sure most people know what ls command is. It's for listing the contents of a directory. So ls, pretty simple. Here's our contents of our directory. Now there's some flags that I like to use here that we'll go over. The first one is the -l command, or the -l flag. That kind of gives you a long list of the same files. So not only does it tell you what files there are, it tells you when they were created or updated. It tells you who owns the files. It tells you what type of permissions are on the files. These can be changed by another unit command that we may get to down the road, but it basically says, I'm the one who created these files, which is pretty standard on your own personal machine. But if you SSH into a server where multiple users have accounts, you may be trying to access a file that you don't have rights to. So the -l flag is helpful for that. The next flag that is helpful for ls is the -a, shows you all the contents. So hidden files, if you don't know what that a hidden file is, it's a file that begins with a period. So if we have a hidden file, it would not show up under a normal ls, but a -a it would show up. We can combine these two, like we can combine most flags with a -al. So here's a list of all the files. We actually see the dot and the 2 dots. One is the current directory, one is the up one directory. So those not really hidden files. All folders have them, but then you see the 4 normal text files. And my favorite flags to use is when I'm in a folder that only contains 4 text files, I'm like, oh, I know exactly which one I want. But if I'm in one that has maybe, I don't know, a couple hundred files and I edited one, I don't remember what it was, I just do the ls lart, which is the al and then reverse by timestamp, and it shows me at the bottom which is the latest thing that I updated. So I updated B, the most recent, so I said, oh, that's the one I was just messing with. So if you ever want to do a sort, which is another command which we'll talk about later, if you just want to say, hey, give me the contents of this directory with the most recent updated one at the bottom so I can see it, then that's what you do. Any questions on the ls command? Cool. All right, next one is another pretty simple one, pretty standard, is the make dir command. So basically it makes you a directory. Make dir foo, and now we can do our ls lart. Foo is at the bottom because it was created just now, and it is a directory. Not much magic going on here. A flag that I like to use is the -p, which lets you create a series of directories with a path. So let me do, let's see, make dir bar, need the p first, bar baz back to foo. It creates bar, and then it creates baz within bar, then it creates foo within baz. So it's a way of kind of stringing out a bunch of make dir statements without having it. If you did that without the -p, it'll say, I don't know what this is. It doesn't work. So you need the -p. So pretty simple. To get rid of a directory, you can use rimdir bar, but it is not empty. We also created a foo, so let's rimdir our foo, which we can do. So to get rid of our bar directory, we have to use a different command, which is just the normal rm command. So rm is for remove. So if we want to remove, we'll talk about this in a minute. Touch high, we can rm high. Rm high, that's how you spell it, which is remove. If you want to remove a directory, we have to do rm-r for recursive, and then we can remove bar. And then that removes bar, all the contents of it, which was baz, and all the contents of that, which is foo. So another command, another parameter you can use is the rf, which is just force. So it's like, hey, you can't delete this because it's tied somewhere. Well, you can force it with a -f, and I was like, fine, you can delete it. Pretty standard, pretty simple stuff. Any questions on the directories or removing files? All right. In Linux, you can use a command to display your file system info. So I'm on my Mac workstation right now, my laptop, and if I use df, it displays the file system info. And here are all of the mounts and maps and linky file things. Since I'm on a laptop, it's not that much because I don't have a lot of mapped drives. If I was on a server, I would say, oh, it's connected to some big standard drive where all the servers are connected to. And maybe if it's a VM, I have a few different sets of storage that are also attached to it. This is not that readable, so you can, using man or -- help, you could learn about this, but I'll just give you df-h. H is for human readable, which we can actually see actual things that we understand. Oh, I understand what 433 gigabytes is, not 9, is that 1,000, a million? I don't know what that is. It's 512 blocks, so it's half, so it's weird. So the -h is always a good thing. Similar to df, we have another command called disk usage, which is du. So our disk usage, which doesn't tell you much here, but if we do du into a, let's see, let me go to this, and this is a, oops, where am I? Let's see. This, and then here, these are some files that I have on my machine, and I needed to put this argument here. So I'm in a place that has a ton of folders. That's why I wanted to come here to see the difference. M for show size in megabytes, H for human readable, and here's a ton of different files that we have open, and it'll tell you the sizes. So you can say, hey, look at all these things, look at how much they are. Later in the lesson, we'll talk about combining arguments with the pipe, and there'll be a way to say, hey, give me the largest 10 files in this path. And so you can say, oh, this one thing is 60,000 times as big as the smaller one. Let's delete this thing because we have disk space issues. All right, that is the DU and the DF. Any questions before I hop on a Linux box? Nope. Cool. So another thing that's helpful is sometimes there are multiple flavors of Linux that are out there. We use Ubuntu, we use Red Hat, and we use CentOS. And so I SSH into a server that my team owns, and I'm like, oh, what version of the OS am I on? So lsb_release-a is the command, and it tells me, oh, I'm on the CentOS box. Okay, great. So I don't need to do I do a yum? Do I do a brew? How do I get stuff on there? Okay, I know what OS I'm on. I know which command I need to run. The LSB release does not work on all OSs. I knew it worked on this because that's what we've been using. So I don't think LSB release works on your Mac terminal, but it does on Linux servers. All right, so we talked about kind of navigating around the file system a little bit. And now let's kind of see what kind of things are running on this box. Does anyone have an idea to find out what kind of things are running on the box? Anyone have any idea?
HTOP.
HTOP will tell you, that's right.
PS.
PS is my jam. I use PS all the time. So PS will tell you the list of resources or processes that are being run. So if we do PS on this box, we see some things. There are a lot of flags that you can pass to PS. So PS, I usually do EAF, which tells me, oh, well, now it's off the window. Sorry about that. It tells you all the things that are being run. This ID here is my user ID. If we do PS on this Linux box, it tells you the actual user that's running it. So it's a little bit different. So I know I'm running a whole bunch of stuff. And this is one of my UAT boxes. So as this user, the user is actually called monitoring dev, but we ran onto characters. It'll tell you all the things that you can do it. And you can actually say, give me all the processes that are run by this user with the -U parameter on the command. Another thing that you may say is, hey, there's this rogue process out there. I see it right here. I don't want this thing on my to be running. I can kill it. So kill is another command you can use. So it would be kill, and then whatever the PID is, the process ID. I don't know what this is going to do, so I'm not actually going to run it. And that would allegedly kill the process. Sometimes it doesn't kill your processes, and you have to be very careful if you want to run a kill -9, which is like, make sure this thing is dead, kill it with fire, and then turn off everything and then blow it up. So kill -9 is another thing. If you're on a VM, you don't have a fancy power switch to cycle to restart your box, because most things in Linux, you don't need to restart your box, but there are a few things that do. And so to do so, you can use the restart or the shutdown command. I usually type in shutdown now -R, which is shutdown right now, don't wait a minute, and R is for restart, which I'm not going to do because that would end this lesson right now. So that's kind of a way to see different things in what's going on in your system. Now let's talk about manipulating files. So I don't know if you saw earlier, I typed the command touch. Touch basically creates a file if it doesn't exist. So it creates an empty file. So we can do a ls, and we don't see a file named foo, so I can just do touch foo. Now if we do ls-long, we see foo and it is size 0, right? So it basically says, here's your file, there's nothing in it. You can then edit that file and put things in it or do what you want with it. Foo is also, or sorry, not foo, touch can also be used to change your timestamp around the file. People in college have done this many thousands of times when they were turning in assignments in late. So if I have a file, so we look at file a.text, and it was updated on yesterday at 4:15, we can do touch -D and then the date. Oops. Let's see, where am I? 06, we'll do it 05, I'll do it a month early. And then 12:30, like this, and then a.text. Oops, what happened here?
-T, not D.
-T?
Yeah, that's what it looked like.
Yeah, it's the wrong one. Maybe that worked on my Linux box, but not on my Mac. So let's see. Oh yeah, it's a different format on here. So I could say help, and then, oops. How come that doesn't show? Man touch. Yeah, so here it is. You're right. So change the access modification times instead of the day. If I would have done it on this box here, which is on Linux, touch foo.text, and then if I would have touch that's because I did it on a Linux box before instead of Mac. Let's see. 01. So it worked here, and now we do an ls-al. We can see, where's my file? Foo, the date changed to May 1st, even though I just made it. So that's basically touch. And it works different on Linux than it does on the Mac. All right, hopefully we'll have no problems like that again, but I'm sure I will because I'm making up as I go along. All right, next one is Concatenate, or CAT for short. A lot of people use this for just displaying contents of a file. So I catted this file. Here's a list of some names and some cities and states. And then we can cat person, which is one, but the whole magic of cat is you can do both. So you can do cat person and people, and it shows you a list of everybody, of the combined. So you can see the last person here, Zach, was added to the output here. So it's a way of jamming everything to the output. We will get into redirection later, but you can do a cat and redirect that to another file, and then it creates takes the output and puts it into the to the file of a new file. So we have head. Head displays the beginning contents of a file. So I'm going to go back to my Linux server over here. So if we go to varlog, varlog is basically where a lot of log messages get put in a standard place. So we can see that this messages file has a lot of lines of text. So if we do head messages, it will only show us the top 10, or the first 10, the oldest 10. We can do head N for number, and then a number messages, and it shows us the first 100 messages. Similar to head, we have the opposite, which is tail. So we can do tail messages and get the last 10 lines. We can also do tail number 100 messages and get the last 100 messages. Not super super helpful, but what I like to do with tail is I like to run tail -f and then the log file. And what that does is it displays the latest 10 messages, but it keeps the process running. So if you go to, let me see if I can actually move this. If you go to the thing that is making messages and another one pops up, so it's basically saying, hey, from now on, show me messages, print the latest message to the screen, which is very helpful in debugging, because you're like, hey, I've got this web app running, I'm tailing the log, and I don't see anything updating as I do things with this web app. So something's not running right. Here, we just saw a few different messages pop up because I went to the actual application that is this log is for, and I did some things, and now it's saying, hey, someone's doing something, so I need to write log messages. Cool. Any questions on this? All right. Silence is golden. Next thing we're going to talk about is we're going to talk about copying a file. So, copy, pretty simple. Copy people, and we're going to copy it to fun.txt. So we have people, we have fun. Let's remove foo. Basically, the same thing is in people as in fun. You see the same size. The timestamp did change to when it was updated and created, which is just now. You can copy files and you can copy directories. However, if we have a directory we're going to try and copy, so let's go up one directory, we do copy test, We're going to call it foo, because foo is what every programmer uses when they don't think of words because they're not creative. It does not work because test is a directory and there are things inside it. So to get around that, we want to make it a what kind of copy? A recursive copy. So we use the flag of -r. And now we can copy the entire contents of test and the directory test and put it in a directory called foo with the entire contents as well. So if we do an ls on foo, we see that the same stuff is in foo that it was in test. So now I will rm, rf, foo to get rid of foo and all the stuff again because we don't need it, back into test. These are pretty basic stuff here. You can move a file or directory. You don't need to do it recursively because it would basically move all the contents of it as well. Let's see, let's go back to here. And we were in the same place as our log files. So another way of viewing stuff. So when we did cat spit everything out to the console, right? So if we're gonna have thousands and thousands of lines of code, we don't wanna put that in our terminal because it's way too much. So we can do something called less, and that will do messages. And then we start at the beginning, and we could go down and do all this stuff. We can do a search for November. Here's November. So we can search our stuff as well using our slash command. So there's a whole man that you can look on this to navigate a less session. There's also more, which is pretty much the same thing. However, less came out after more, and less is more actually. More is a little bit slower because it has to load all of the contents of the file into memory before it displays it, whereas less does it as it's needed. And in more, you can't navigate up; you can only navigate down. Sorry, you can navigate with the up and down arrows in less, and not in more. Another thing that I like about less is that if we do less hyphen capital N for our stuff, we add line numbers. So it's a good way of referencing stuff. That's just one of the flags. All right, so let's go back to this page here. Sorry, this page was not visible. I'll put that like that. All right, so the next thing we're going to talk about is a symbolic link or a symlink. Have you gone over symlinks? Does anyone know what a symlink is?
Nope.
Oh, okay, that's fine. That's fine.
It's like creating a shortcut to a file or a folder.
Yeah, so it's creating a shortcut to a file or folder. However, it's not like a shortcut that you would see in Windows where you right click, create shortcut, and then drag it somewhere like, oh, I want a shortcut to this application on my desktop. Symlink actually creates the makes it appear that the object is in its actual location where you created it. So it's not it is a link to another object, but it makes it look like the object is there, so you can run the same stuff from there. There's a few reasons why you would use a symlink. We use them a lot at DRW. I'm sure most developers use them for different things. It's great when you have to access the same file in multiple spots. So if there's a config file and you're like trying to test out different versions of your app, and you all need to touch this one config, it's like, well, let's not create different copies of that in our different apps. Let's just symlink to the same thing. So if someone edits the symlink or the object that is in the symlink, it gets pushed out to everybody. Another way that we use it at DRW is that when we deploy an application to either our UAT or our prod environment, is that we kind of keep histories or historical records of the Git pushes of each previous release. So if we have 6 releases out there of an app, we create a 7th release based on the SHA of the git commit, and then we would link that to a folder named current. So everything is always run out of the current symlink, which points to the latest version, but you're like, oh, we pushed this out and it's not working. We have to roll back to the earlier version. We don't have to worry about recompiling an earlier version or finding it and pushing it out. It's still on the box. We just change the symlink to point to a different SHA that corresponds to the earlier version. Does that make sense? Let's see if I can show you something like this. So let me go to, this is one of our boxes. Let's see. So let's see, we're going to go into something called Bon Appetit, which we made here at DRW, which is our, it's our menu system. We have catered breakfast and lunches. So this is the thing that displays all your food, and you get to vote on how well you like the stromboli. Let me do this way. All right, so here are SHAs of different versions of the app. And the last one we have is this 7 Alpha Alpha Bravo 6 Delta 4, which is symlinked from current. So anytime we want to make a restart, we always go into current, but it points there. Now let's say that 7 Alpha Alpha is bad and we need to roll back to 5 Delta Echo. We can just remove the symlink and then create a new one that points current to whatever version we want, 8 Delta Echo. And that's a quick way of rolling stuff back, besides like pushing out to production and all that kind of stuff, because it's already on the server. Does that make sense? All right, next command is I've got too much crap on my screen, so I want to clear it. So I just type in clear without the T because I'm dumb, and we just go back to a blank terminal. All right, so yeah, symlinks are pretty good. The next thing is, well, I need to run, let's say, Python 3 for something. Now, there are multiple versions of Python 3. There's Python 3.5, 3.6, 3.7, 3.8. I'm sure there's going to be a 3.9 and all the sorts of stuff. It's going to be very fun. So you can use which to find out where your Python 3 is. Here, so this is where my Python 3 is located. However, there's a problem with which, and that problem with which is that it finds the executable of the thing that you're doing. It only works on executable. So if you have an alias or a function, which will not find it. So I encourage you to use type. Type will basically input the same, output the same result. But it works with more types of files, aliases and functions. So you're like, oh, I'm running this version of Python, but oh wait, my Python 3 is in user local bin and not user bin. What's going on? So you can figure out where your Python is running from, or whatever you're running, where it is in your system. Another thing that I like to do is make an alias. Aliases are really cool because there's commands that I type over and over again that I get annoyed with, that I have to type over and over again. So I make aliases that are basically shortcuts to commands. So an alias, just to see a list of aliases that I have, I can do an alias and then a -p, I believe. And here are my aliases. So how many times have you run Python virtualenv create Python venv blah, 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 blah? I've run that so many times. So I just made a alias called VV. I type that, and then it runs that whole command. And as you can see, I'm using which here and not type because I only want this output and not Python 3 is. So that's why I have that there. So VV creates a virtual environment for me, so I don't have to type in virtualenv Python, which Python 3, venv. So you can always say alias foo equals ls lart, since we've done that one already, and then I do foo, and foo is now a command, or it's an alias. Oh crap, foo is a reserved thing that I need to use for something else. I need to get rid of that alias. How do I do so? Well, I unalias foo. And now if I type foo again, it doesn't understand what foo is. So aliases are pretty helpful to have. In your bash RC file, your bash profile, you can create a section for aliases that you use. I have the same bash RC file shared across my workstation and my laptop. So all my commands are always up to date. Cool. All right, let's talk about find. So I have in here, let's see, I'm gonna go, so find is a way of finding the name of a file. So not the contents of what's in the file, but the name of a file. So if I do find, and then I do, let's see, /dev pers, which is my personal stuff that's not work related, where this is, and then iname, and then people.txt. It'll say, hey, there's a people.txt in this path. Yeah, I found that file. If I did that in my root directory, I would get a lot of you're not authorized to go in this folder because it's some system folder messages. So that's a way of saying, hey, can you find my file? And I'll say, yeah, sure, I'll find your file. And then I can also do another type of find, which is what I prefer to use, called locate. Locate is, say, locate wherever there's a people.txt. So as you can see, find, I had to put a location where I wanted to start from. Locate is a process that's kind of runs in the background to index all your files. And then locate will say, hey, here's a quick search of your file system. Here's what you can see. There's a people.txt in my personal test directory, and also in this local Erlang thing, long thing people.txt. I don't know what that is, but there's a people.txt file in it. So that's another way of finding stuff. You're like, oh, I have this thing, I have no idea where it is. Locate, and if you have it set up, then it will find it for you. You do have to do a little bit of work before it gets set up for you. I think you have to create the database that it indexes to. It's pretty quick to do that, and then it will start indexing for you. Any questions on locate? All right, we will move to the next thing, which is getting things from the internet. So the two commands that I use often to pull things down, first one is wget. So you may have used this while installing packages. There's a lot of places like, oh, I need to get this this app, so you can just wget it from the internet with a long path and make sure everything checks out, and then you type in wget and then whatever it is, and then it pulls it down. Also something called curl. Curl is how we kind of get data down. You could curl files down, but this is I use this more for curling data down. An example for that is we have at DRW an on-call calendar in JSON format. So if we want to do curl, let's see, I'll just actually run it, ITS on-call calendar JSON. If I do this, it should return with a JSON blob of whoever's on call for each department at this current time. And there it is. So there's a big JSON saying, hey, this Linux desktop person who's on call, tells you who's on call. So curl is good to pull data down from different apps. There needs to be, if you're trying to run a curl on an app that you've made, you need to make sure your route is open for it. But that's how it works. All right, let's talk about redirection. You can redirect standard in, standard out, standard error, that kind of stuff. The stuff that I use the most is redirecting standard in, standard out. And the way to do that, and we'll actually use, let's see, we'll do echo. Echo is just kind of like a print for here. So if we do print foo, it says foo. So we're gonna echo foo, redirect that instead of the console to foo.txt. So we don't see anything in the console, but we have redirected using the square bracket or greater than sign or whatever you want to call it to a file. So now if we cat our foo, we see that whatever we redirected were there. If I do it again, a couple times, we can now do cat foo, and we still see just the one thing. If we have two brackets, angle brackets, instead of overriding it, it appends it. So now we can see that there are two foos. All right. The next thing I want to teach you about is a pipe. It looks like this. It's a way of, let's see, what do they call it? It is a way of redirecting a stream, the standard out or whatever stream, to another program. So let's take a look at this curl command I just did, and I want to pipe it to, let's see, oncall.json. Sorry, not that. I want to pipe it to oncall.json. So it says, okay, I'm transferring all this data information. Instead of your screen, it goes to oncall.json. We can actually remove the this message with a -s for silent. So if we now, we'll do less, oncall.json, here's the contents. Have you guys got much into JSON data yet?
We're just starting to scratch the surface with it.
Okay. JSON is a standard way that applications send information back and forth to each other. JQ is the name of a program that is free and is great, that kind of lets you manipulate your data and makes it print. It prints it out to the screen a lot prettier, and you can say, I want just escalation numbers, or just names, or just this. So it lets you, it's kind of like a regex for JSON. So if we do our curl command and pipe it to JQ, and the format is JQ hyphen, it looks so much better, right? So that's a way of getting it, and then we can pipe, and then we can redirect it to our oncall.json. Now if we look at oncall.json, it's a much easier way of doing it. And you can pass in parameters instead of the dot to just display part of what you want. So I think if you do something like, let's see, name, yeah, so we have to have this, and then that gets rid of the array here. So now we're out of the array, because before we were in an array. Oops. And then we want to pipe in, let's see, name, like this. And because we are using this pipe within this, or the second pipe within JQ, we have to quote it. And now that gives you just the names. So I would encourage you to look through the docs for JQ once you start playing around with your JSON. All right, let's see, what is next? So let's talk about more things that the pipe can do. Where am I? LL that I have is an alias for ls-al, so that's why I use that. Let me look into fun. What is fun? Cat fun. All right, here's some things. Oh yeah, I remember making this. It's the same as people. So let's rm fun, and let's cat people person, and I'll put that to all.text. So now cat all should have Zach is from the other file person, and everyone else is from people. Now let's get a little fancy with our pipes. So I am going to use something. I'm gonna sort them. So now if we do cat all, and we pipe that to sort, it sorts them alphabetically, right, with the first character. So Betsy wasn't first, I was first, but she overtook me in the race, and now I'm second to last. So that just alphabetizes based on the first letter in the row. We can do sort R for reverse, and I'm back to second place. We can also, let's see, let's cat all and then people and put that to dupes.txt. So if we cat dupes.txt, we can see there's duplicates. So now if we want to get rid of those dupes, we can cat dupes, sort them, and then add the unique. So it only has single line, so it gets rid of all the duplicates, like that. You know, let's make this even fancier and say, I want to create a, we'll take this file, we'll remove dupes, we'll do all. I want to take the contents of this file and I want to create a directory based on names of cities. So I want to create a directory for Chicago, one for Pittsburgh, one for Portland, one for Richmond. We already have Portland, so I don't need another one, and one for Carborough. So what we can do is use awk. Awk is a way of playing around. It's a scripting language. You could use it to manipulate your data. So I use this with redirection. So if I do cat all and I pipe it to awk, then I can do print $3 because it's the third column. Now we have just the cities. So awk separated these as space delimiters into different columns, and I do $3 to get the third one. And then if we do sort, and then we do unique, we have just the cities. And then we can even use something called Args, which takes the standard out of what each line is an argument, and I want to pass those arguments to make dir. So this command right here should create 5 different directories, one for each of those lines. So I do that. I do my ls, al, let's do lart, just to see at the bottom. And now we have 5 directories. One of the things that is very helpful is to learn how to chain stuff together. Whether it is you're curling through logs and you're trying to find stuff, you pipe it to something, you grep it out, which we'll talk about in a second. You sort through it and you try and figure it out. And learning these type of tools will help you troubleshoot problems a lot faster than trying to use your eyes. Because I've always missed things like, oh, I didn't see that line there. Like, oh, well, if we have a computer do it, it should make it simpler. Let's talk about grep. Grep is a global regex. So if we, so I can use grep. I'm going to add -r for recursive, and I'm looking for something within a file. So before, when we did locate and find, we were looking for actual names of files. This is looking for content within a file. So I remember that I put my name in one of them. So I'm going to search for Renee. I'm using dot because it's going to be here. And so any file that has the name Renee, lowercase, in it should come up. Okay, so I see I am listed in all, I am listed in people, and in some binary files, it's saying, hey, I think you're listed because I created them.
Is it only inside files? Will it also match file names?
It will not match file names.
Okay.
So if I do a touch renee.txt, and then I do grep Renee, it does not list renee.txt.
And it's case sensitive?
It is case sensitive, but there's a flag that you can pass to make it not case sensitive. So let's actually look at that. So let's do grep help, let's do man grep because that's very compressed grep. And then we can search for case, ignore case. So an I would do that for you. So if we do, let's open up, I'll use Vim to edit people.txt, and I will make this capital. And now if we do grep Renee, I only see the first one plus some binary files. I'm actually gonna rf inv to do it again. We only see that, and now we put I for ignore case. We see both. Very helpful in like, oh, I'm on my app and I see this error message. I don't know where that error message is coming from. So I'm gonna grep my app code to look for it, and it's like, oh, it's in this file here. Great. Now that's where my problem is. All right, so that is grep. Let's see. Let's look at a bigger, let's see. Am I there yet? We talked about awk, we talked about JQ. Oh, another thing that I really use often is a command called history, which means, man, 3 hours ago I did something and it worked. Now it's not working. I don't remember what I did. I type in history, and here's a list of all the commands that I've done. Like, oh, wait, it's over here. So I know it had something to do with SSH. I don't remember which box I went to. So like a good developer, I pipe it and I do a grep for SSH. Like, here's all the stuff that I've SSH'd. It's like, oh, here's the box that I was looking for. This box right here. And then then if I want to actually execute that command, I can type in bang or pound or $, and then the number, and then that basically runs whatever it is, which we don't need to do right now. Another fun thing is if you ever do bang bang, it is run previous command. So I run that whenever I try and do something on a box, and I'm like, oh crap, I'm not sudo. I have to be a super user to do this. So I type in sudo bang bang to run the previous command with my super user sudo rights. All right, let's see. So yeah, history is great. Let's see. An issue that you probably won't come across while you're at Platoon, but once you start hacking around files as a professional developer, you may come across, hey, I've got this application that's running on this server, and it's supposed to be collecting data from this database over on this server, but it's sending stuff to another application on this server, and I can't connect to this port on this server for some reason. It's just blocked. Well, let's look at something called IP tables. IP tables lets you see the incoming, outgoing traffic to the box, or lets you block it and see what's available. So I'm on my UAT box here. So if I type in IP tables, and then the command is capital L, or the parameter is capital L, I should, wait, I have to be sudo, so I have to run this. Here are all of the permissions for TCP and UDP and all this kind of networky stuff. So I can tell that these ports are available. And oh, what's this on my box here? It says reject everything else. So it's saying, hey, here's some ports that I'm letting open, but I'm blocking everything else. And I'm trying to connect to port 9000. Well, 9000 is not listed here, which means it automatically defaults to reject any incoming traffic. So down the road, when you're like connecting different apps to different things, there are sometimes firewall rules that you'll have to deal with. There's sometimes rules within the network, firewall rules, but there's also these IP tables. Some boxes don't have any IP table rules, like let me talk to anybody, I don't care, but stuff where data may be sensitive, or you have to have certain permissions to do it, or things are in the DMZ that we're blocking it as much as we can. This is how we punch holes through it. You may have to deal with IP tables. All right. Yeah, that's more of an FYI, not really to worry about right now. Let's talk about how our packets get to where they need to go. So we're kind of delving a little bit into networky stuff. Traceroute is a good way of saying, hey, I want to go to www.google.com or coplatoon.org or whatever web page we want to go to, or whatever app we're trying to go to on the web. What am I actually doing? It's not going directly there. It's probably having 5 or 6 or 20 intermediate stops. So if we do a trace route to where you want to go, it says, oh, I started here, and then it went to this IP address, and then it took time here, and then it went over here. I don't know what Cogentco is, but it's somewhere. Then it hit these IP addresses, and oh, it finally ended where I needed it to go. So that's a way of saying, oh, wait, I know there's a problem with this node because it's still in our internal network and they're doing replacement stuff on that server or on those switches. So that node is having issues. It'll tell you if things time out. You can actually see how long it takes to get from one node to the next on your route. So that's kind of helpful with troubleshooting some network issues that go outside your company firewall. We go to Tata, all that kind of stuff. How much time do I have, by the way?
We have like to when?
What time? Till 2
till,
or?
Yeah, about 2. You can go a little bit after that.
Okay. Well, we're mostly done. Just wanted to show a few more things here. Let's go back and let's see. When I was at the let's see, dev, des, tet, Concatenate. When I was in this thing looking at the size of files, and we ran that command. Oh, I don't remember that command. What was it? History grep, which I actually made an alias for called HG because I use it often to find out the size of files. So we'll do du. Yeah, here it is. So du-m. So if I want to run 20, 50, here's all the files. There's a ton of stuff in there. But let's say you're on a box and this box has, I don't know, 3 terabytes worth of storage. And we come across this on Des often is we do all the automated builds for the firm. So different teams will build stuff, and some of it's small, some of it's really large, and they keep artifacts on there. And like, hey, our disk is filling up, so we need to kind of eliminate the top 5, top 10 artifacts that are stuck on this build server that need to be pushed off onto some network sharing that's used for that. So if we do a du-a and then we do a sort numerically recursively, and then we use our head command and see the 10, here are the top 10 large size files in this giant thing that has 1,000 files on it. Maybe we can do H to see human readable. Yeah, so this is only a meg. This is only, it's not that big, but there's a lot of stuff there. There's a lot of files. And on a server where there's giant log files that don't have any log rotations or anything like that, where you keep adding records and you never delete anything, things can get pretty big pretty quickly if things spin out of control. So that's a way of kind of determining what needs to be looked at. Now let's talk a little bit about date, the command date. So pretty simple. It tells you what the current date is. A lot of the apps that we use milliseconds since the epoch as a timestamp. So there's a simple date conversion for that. So if you want to see what the current milliseconds since the epoch is, you can do date and then plus, it's not plus, this is plus, S, and then that will show you how many milliseconds since the epoch. That is a milliseconds or seconds since the epoch, or milliseconds since the epoch, based on, I think it's January 1st, 1970, but it is a common software development timestampy thing. At least it is a DAW. And if we want to convert a string of numbers like that, or a long number like that, into current time, you can do date, and then -d, and then @ and whatever that number is. And it will convert it back. Oops, that didn't work. Maybe that works just on Linux. See if it works over here. There you go. So a lot of the JSON records that we get, the data that I get from the apps that I use, I always have timestamps in this millisecond since the epoch format. So I was like, oh, what the hell does 15364 mean? When was this thing done? So I always have to run it through this or some other app to convert it to human readable time. Last thing I want to talk about is curly brackets. Curly brackets are great for creating a sequence of things. So we all know about echo. Echo basically prints something to the screen. So if we do echo 0, and then echo 1, and then echo 2, we're printing 0, 1, 2. But we can do echo, left curly bracket, 0, ... 10, and that will create a sequence of echo statements. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can do that. So that was ascending. We can do it descending, 2019, 15, blah, blah, blah. And then we can also do that with letters. We can do that with letters, and instead of going every letter, we can do every other letter. Oops, that's supposed to work. How come that didn't work? Does that work on Linux and not on Mac? Yeah. Good old ASCII. Yeah, that's right. It's probably just a different syntax. This is helpful when you're like, hey, I need to create a whole bunch of files and they're very similar names, or I'm doing something with directories and they're very similar. You can do something like touch foo underscore 1 ... 10. And that created 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, there's no beginning 0 there. So if I do rmrf foo, let me go, let's see. You just start it with a 0. And then we do, oh, that should work. This could also be another Unix thing, a Unix Mac thing. That worked before on my workstation. Let's see. Last thing is we were in a completely different directory. If you do a cd hyphen, it takes you back to the previous directory that you were in. It's kind of like push D, pop D, if you know those terms. So we're back here. I think that's all of my ramblings. What kind of questions do you have for me?
Was that the last command the same as ... or is that different?
That is ... sorry, that is different. So cd ... will take you up one folder. So if we look at pwd, and then I go to test, and then I look at pwd, we are in one directory over. Now if I go to cd, let's see, we'll go dev, mont, some other thing. So if I do cd ... that will take me up one direct. Let me do pwd first. That'll take me to this users are Duquesnoy dev monstack junior. cd ... takes you to up one folder. If I did a cd dash, that will take you to the previous folder that you were in. So I'm going to go cd dev here, pwd, and now cd hyphen will take me all the way back to users are Duquesnoy dev monstack. And does everyone know what cd tilde is? That takes you to your home directory. So my home directory is just users are Duquesnoy. On your Linux box, it's home username. Other questions?
Is everything you showed part of the standard terminal, like the trace thing? That's not an installed program. It's part of the terminal.
Yeah, I believe it's part of the terminal. If you have if you have a terminal now, it should work. I don't remember installing Traceroute.
Okay, thanks.
Is there a big difference between using Bash or Z Shell, or what recommendation for either one?
That is a great question. Bash is standard. Z Shell is kind of like the new hotness. It's not new, but it's there are some good things about using Z Shell. One of the main things is your history is shared across terminals. So I have 2 terminals up. I'm working on something, and then I close my terminals, and I do a history or something like that. It's not in my history because it was saved in a different file. Z Shell combines all of the history together. I would look at Z Shell. Yeah, it's pretty good from what I can tell. I have it installed on my Linux box.
Okay, thanks.
Doesn't Bash store all the history from the terminal in .bash_history? So couldn't you access that from 2 different terminals?
Well, if I typed in, let's see, echo foo on one terminal, I create a new terminal, I type in history. I don't see my echo foo.
Okay.
Z Shell would store it all in the same place.
Also, some of them have limitations of how many history items you could share. I think Bash does, 2,000 by default. So if you wanted to store more, doesn't matter, Z Shell or Bash, you could edit one of the profiles to store all of your history from.
Any other questions?
Yeah, can you explain push D and pop D a little bit more? I use it to like cache one, but I thought you could use it to like make a stack of directories, and I can't seem to figure that out.
All right, so let's see. And push D, just so we're all on the same page. Why did that show push D stuff? Push D, help. Do I have push D in this? Okay, so push D. So I'm here, and then I push D to some place completely new, temp. And then I pop D, I'm back to dev. So it stored a stack, right? It's not a FIFO queue, it's a stack. Does that says what I just said? So I push D to dev first, then dev goes at the bottom, and then I push D to a different directory called temp. Temp goes on the top, and then when I pop it, I go back to then I do what I do, and then I pop D, then I go back to the one that's directly underneath it. I'm not sure if I answered your question or just talked around it.
You did. I don't know if I'm making a mistake or what. I can't seem to get pop the last one off, and I was using it to like just push the current directory. So if I don't give it an argument, will it just push the current directory? And when I pop it, it puts me into the next directory from the top of the stack. That's correct, right?
So it looks like when I did a push D without anything, it pushes you into your home directory. It pushes the home directory there. Yeah, so now it's empty. There should be a good Googleable tutorial on this. Let me see if I can find it. Yeah, so if we do, let's see. So push D personal test, and then I do a mkdir -p foo bar baz, then I push D foo, and I push D bar baz, and then where am I now? I'm in foo bar baz, and then I pop D, and do you think I'll be going to foo or I'll be going back to my dev root directory? I think I'm going back to foo. Yeah. And then if I pop that off, I'll end up where I started from, which is in my dev directory. Well, I'll be in test and then I pop another one off. I'll be where I was in the beginning. Is that good?
Yes, thank you.
Okay. Next question. Going once? Going twice? All right. That is what I got.